The darkness beyond. Picture this. You wake up tomorrow and 95% of your world has vanished. Your house? Gone. Your car? Gone. Your friends, your family, your entire neighborhood? All of it. Invisible. Only 5% remains. A single room, a chair, maybe a lamp. This isn't science fiction. This is the universe we actually live in. Everything you've ever seen, every star, every planet, every galaxy blazing across the night sky, represents less than 5% of what's actually out there. The rest? We call it dark matter and dark energy. But we might as well call it, we have no idea. Welcome to the year 2025, where humanity has split the atom, mapped the human genome, and taught machines to think. Yet we're still living in a cosmic mystery novel where we haven't even finished reading the first chapter. Today, we're going to explore the biggest unsolved mysteries in physics, the questions that keep Nobel Prize winners awake at night, the problems that have stumped the smartest minds on Earth for decades. These aren't just academic puzzles, they are the keys to understanding everything: who we are, where we came from, where we're going. And the strangest part? Some of these mysteries are getting deeper, not shallower, the more we learn. If you're fascinated by the unknown edges of science, hit that subscribe button, because today, we're diving into territories that would make Einstein's head spin. Chapter 1. The Ghost Universe. Let me tell you about Vera Rubin. In the 1970s, she was doing something that should have been routine, measuring how fast galaxies spin. She expected to find what you'd expect from basic physics. Stars close to the center should move fast. Stars on the outer edges should move slower. Like planets in our solar system, Mercury races around the sun while distant Pluto crawls. Instead, she found something impossible. The outer stars were moving just as fast as the inner ones. It was as if you threw a baseball, and instead of following an arc and falling to the ground, it just kept going straight, forever. The galaxies were breaking the law. Newton's law, Einstein's law, every law we knew. Unless there was something else there, something invisible, something that had mass, created gravity, but couldn't be seen. They called it dark matter. And here's where the story gets truly bizarre. Today, in 2025, we know that this invisible stuff makes up 85% of all matter in the universe. Think about that. Everything you can see, touch, or measure represents only 15% of what's actually there. It's like discovering that your house sits on an enormous, invisible foundation that's 6 times larger than the house itself. But wait, it gets worse. In 1998, astronomers made another discovery that shattered everything they thought they knew. They were studying distant supernovas, exploding stars so bright they can outshine entire galaxies. These cosmic lighthouses allow us to measure distances across the universe. What they found was that the expansion of the universe wasn't slowing down, as everyone expected. It was speeding up. Something was pushing the universe apart, faster and faster. They called this mysterious force dark energy. And this invisible pusher? It makes up 70% of everything that exists. So let's do the math. 70% dark energy, 25% dark matter, 5% normal matter. We live in a universe where 95% of reality is completely unknown to us. Imagine being a detective and discovering that 95% of the crime scene is invisible. That's where physics stands today. But here's where it gets even stranger. In November 2024, a physicist named Rajendra Gupta published a paper that turned everything upside down. He proposed that dark matter and dark energy don't exist at all. Instead, he suggested that the fundamental forces of the universe are getting weaker as the universe gets older. It's like discovering that gravity itself is aging. If he's right, it means we've been chasing ghosts for 50 years. The universe isn't filled with invisible matter and energy. The rules of physics themselves are changing. Most physicists are skeptical. But then again, most physicists were skeptical when Einstein suggested that time could slow down. The truth is, we're still groping in the dark. Chapter 2. The Information Assassin. Now, let me tell you about the most famous bet in physics. In 1997, 3 of the world's smartest people made a wager. On one side, Stephen Hawking and Kip Thorne. On the other side, John Preskill. The stakes? Not money, pride, and possibly the fate of physics itself. The question, when you fall into a black hole, does the information that makes you survive? Or is it destroyed forever? This might sound like a philosophical question. It's not. It's the difference between a universe where the laws of physics make sense and a universe where they don't. Here's the problem. Quantum mechanics says that information cannot be destroyed, ever. It's one of the most fundamental rules of reality. You can scramble information, hide it, transform it, but you cannot make it disappear. But black holes seem to do exactly that. When Stephen Hawking calculated what happens at the edge of a black hole in 1974, he discovered something shocking. Black holes aren't perfectly black. They emit radiation. And over billions of years, this radiation causes the black hole to shrink and eventually disappear completely. But here's the kicker. Hawking's calculations showed that the radiation coming out was completely random. It contained no information about what had fallen in. If you fell into a black hole, the universe would lose every bit of information that made you unique. Your memories, your DNA, the arrangement of every atom in your body. Gone. Forever. This violates quantum mechanics so completely that it's like discovering that 2 + 2 sometimes equals 5. The problem became known as the black hole information paradox, and it's been driving physicists crazy for 50 years. Hawking believed the information was destroyed. That's why he bet against Preskill. But in 2004, something changed Hawking's mind. New developments in string theory suggested that the information might escape after all, encoded in the radiation in ways too subtle for us to detect. Hawking conceded the bet. He bought Preskill a baseball encyclopedia, because Preskill could look up information that was never really lost. But the story didn't end there. In 2019, a group of physicists led by Ahmed Almheri made a breakthrough. They developed something called the island formula, a mathematical tool that tracks how information escapes from black holes. Their calculations showed something remarkable. Information does get out, but not in the way anyone expected. Instead of leaking out slowly over the black hole's lifetime, the information remains trapped for most of the evaporation process, then suddenly gushes out all at once near the end. It's like a dam that holds back water for years, then suddenly bursts. This created what physicists call the page curve, a graph that shows information being preserved throughout the entire process. But here's the catch. The mathematics that makes this work is so strange that some physicists question whether it describes reality at all. The latest calculations suggest that the interior of a black hole might not even exist in the way we imagine. Instead, it might be encoded on the surface, like a hologram. If that's true, then when you fall into a black hole, you don't actually fall in. You get smeared across the surface and encoded as information. From the outside, you'd appear to freeze at the edge and slowly fade away. From your perspective, well, that's where the math gets really weird. The point is, even in 2025, after 50 years of work by the smartest people alive, we still don't know what happens when you fall into a black hole. And that means we don't really understand the universe at all. Chapter 3. The Millennium Failures. 25 years ago, physicists were feeling pretty good about themselves. They had discovered most of the particles in the Standard Model. They had detected gravitational waves. They had evidence for dark matter and dark energy. They were so confident that they decided to make a list, the 10 biggest problems in physics that they were sure they'd solve in the new millennium. It was 2000. They called them the Millennium Problems in Physics. Now it's 2025. 25 years later. Want to guess how many they've solved? 0. Not a single one. In fact, some of the problems have gotten worse. Take supersymmetry. This was supposed to be the crown jewel of particle physics. The theory predicted that every known particle has a superpartner, a heavier hidden twin. If true, supersymmetry would solve multiple problems at once. It would explain dark matter. It would unify the forces of nature. It would resolve mathematical inconsistencies in the Standard Model. Physicists were so confident that they built the Large Hadron Collider partly to find these superpartner particles. They spent $10 billion. They've been smashing particles together for over a decade. They've found nothing. Not a single superpartner particle. The energy range where supersymmetry should appear has been completely ruled out. Either supersymmetry is wrong, or it's hiding in energy ranges so high that we'll never reach them. The same story applies to extra dimensions. String theory, the supposed theory of everything, predicts that space has 9 or 10 dimensions, not the 3 we experience. Where are those extra dimensions? curled up so tightly that we can't detect them? How do we test this? We can't. String theory has produced 0 testable predictions in 40 years. Then there's the hierarchy problem. Why is gravity so much weaker than the other forces? If you can lift a paperclip with a small magnet, you're overpowering the gravitational pull of the entire Earth. Electromagnetic force is 10 to the 39th power times stronger than gravity. Why? Nobody knows. The cosmological constant problem is even worse. When physicists try to calculate how much energy empty space should contain, they get an answer that's wrong by 120 orders of magnitude. That's not just wrong, that's the most wrong prediction in the history of science. It's like predicting that a baseball weighs 1 gram and discovering it weighs more than the observable universe. And dark energy? We know even less about it now than we did in 2000. Recent observations from the Dark Energy Spectroscopic Instrument suggest that dark energy might be changing over time. It might be getting weaker. If that's true, it breaks our understanding of fundamental physics in entirely new ways. So much for the millennium. Chapter 4: The Quantum Gravity Graveyard. But perhaps the biggest failure is also the most fundamental. We still can't unify quantum mechanics and gravity. Einstein spent the last 30 years of his life trying to solve this problem. He failed. Every physicist since has failed. And it's not for lack of trying. String theory? 40 years of work by some of the smartest people alive. 0 experimental confirmation. Loop quantum gravity? Beautiful mathematics. No connection to reality we can test. Causal dynamical triangulation? Emergent gravity? Asymptotic safety? All brilliant ideas. All stuck in theoretical limbo. The problem is fundamental. Quantum mechanics and general relativity describe reality using completely different languages. Quantum mechanics says that at the smallest scales, everything is uncertain, probabilistic, weird. General relativity says that space-time is smooth, deterministic, classical. Try to combine them and you get infinities, meaningless results, mathematical gibberish. It's like trying to write a love song in 2 different languages that have no words in common. The failure runs deeper than just equations. It reveals that our most fundamental understanding of reality is broken. Consider this. Every other force in nature, electromagnetism, the strong nuclear force, the weak nuclear force, has been successfully described by quantum field theory. But gravity? Gravity refuses to play by quantum rules. Why? Nobody knows. Some physicists think the answer lies in recognizing that space and time themselves might be illusions, that at the deepest level, reality might be made of something else entirely. Others think quantum mechanics itself is incomplete, that we need a new theory that goes beyond both quantum mechanics and relativity. A few brave souls think we need to abandon the idea of unification altogether. Maybe gravity and quantum mechanics describe different aspects of reality that can never be combined. But here's what keeps me awake at night. What if we're not smart enough? What if the human brain, evolved to throw spears and gather berries, simply lacks the cognitive architecture to understand the deepest truths of the universe? What if the theory of quantum gravity exists, but it's written in a language that human minds can never speak? We're halfway through our journey into the unknown, and things are about to get even stranger. If you're enjoying this deep dive into physics mysteries, share this with someone who loves science. They'll thank you for it. And let me know in the comments, which mystery fascinates you most? Chapter 5: The Consciousness Bombshell. Speaking of things that might be beyond human understanding, let's talk about consciousness. For most of physics history, consciousness was considered outside the domain of physics. It was a problem for philosophers, psychologists, maybe neuroscientists. But recently that's changed. And the reason has to do with quantum mechanics. In 2024, something remarkable happened. Google's Quantum AI Lab, led by a physicist named Hartmut Neven, announced that they were seriously investigating whether consciousness might be a quantum phenomenon. This isn't fringe science. This is one of the world's leading quantum computing labs. Their hypothesis is radical. Consciousness might be the mechanism by which humans experience one branch of the quantum multiverse. Every time a quantum event occurs, and quantum events occur billions of times per second in your brain, the universe splits into multiple realities. According to the many worlds interpretation of quantum mechanics, All of these realities are equally real. But consciousness, Nevin suggests, is what allows you to experience just one. It's consciousness that collapses the wave function. Not measurement, not observation, consciousness. If true, this would mean that consciousness isn't produced by the brain. It's a fundamental feature of reality, as basic as mass or charge. The idea isn't entirely new. Roger Penrose and Stuart Hameroff have been arguing for quantum consciousness for decades. They propose that consciousness arises from quantum effects in microscopic structures called microtubules inside brain cells. Most neuroscientists have dismissed this idea. The brain is too warm and wet for delicate quantum effects, they argue. But in 2024, new experiments changed the game. Mike Wiest at Wellesley College did an experiment with anesthesia and rats. He gave the rats a drug that binds to microtubules, then put them under anesthesia. The result? It took significantly longer for the rats to lose consciousness. The drug interfered with the anesthetic's ability to knock out the rats. This suggests that anesthesia works by disrupting quantum processes in microtubules. And if anesthesia disrupts consciousness by disrupting quantum processes, then consciousness might indeed be quantum. Other experiments have found quantum effects in microtubules at room temperature, something that was thought to be impossible. But here's where it gets really weird. If consciousness is quantum, then the hard problem of consciousness, how subjective experience arises from objective matter, might not be a problem at all. Subjective experience might be what quantum mechanics feels like from the inside. When an electron is in superposition, existing in multiple states simultaneously, what does that feel like for the electron? We've always assumed it feels like nothing, that consciousness requires complex brains. But what if we're wrong? What if consciousness is what it feels like to be any quantum system resolving into a definite state? What if the universe is literally conscious, not metaphorically, literally? This is panpsychism, the idea that consciousness is a fundamental property of matter, like mass or charge. It sounds crazy, but it might be the only way to solve the hard problem of consciousness and the measurement problem in quantum mechanics at the same time. Chapter 6. The machine profits. But here's where the story takes its strangest turn yet. Just as we're beginning to suspect that consciousness might be fundamental to physics, we're creating artificial consciousness. AI systems are now making discoveries that human physicists missed. They're finding new materials, predicting protein structures, discovering new mathematical theorems. DeepMind's AlphaFold solved the protein folding problem, a challenge that stumped biologists for 50 years. AI weather models now outperform traditional physics-based models. Machine learning algorithms are discovering new phases of matter that human physicists never imagined. The AIs don't understand physics the way we do. They don't work from first principles. They just find patterns in data that we missed. But here's the terrifying part. The patterns they find are real. If consciousness is fundamental to physics, and we're creating artificial consciousness, then we might be on the verge of creating entities that can perceive aspects of reality that we cannot. What if AI doesn't just solve our physics problems? What if it solves problems we didn't even know we had? What if artificial consciousness can directly perceive quantum superposition? What if it can sense dark matter? What if it can navigate extra dimensions? We might be creating our own successors, entities that will understand the universe in ways we never could. The question isn't whether AI will be smarter than us. The question is whether AI will be more conscious than us. Chapter 7. The Observer Paradox. But there's one more mystery that's emerged just in the last few years, one that threatens everything we think we know about existence itself. In 2024, physicists made a disturbing discovery. Using the mathematics developed to understand black holes, they tried to model a closed universe, a universe like ours, but completely sealed off from anything external. What they found was impossible. According to their calculations, a closed universe can exist in only one quantum state, not multiple states, not a superposition of states. One state. A universe with the complexity of a single bit, zero information content. But that's ridiculous. Our universe clearly contains enormous complexity. Stars, galaxies, planets, life, consciousness. How can a universe contain vast complexity and no information at the same time? The answer, some physicists now suspect, is observers. Information might not exist without consciousness to observe it. Complexity might not exist without minds to perceive it. In other words, reality might literally depend on observation. Not just quantum mechanics, reality itself. This is the observer paradox, and it's the newest and perhaps most disturbing mystery in physics. It suggests that the universe without observers would be a single, simple, empty state. Everything we see, everything we are, might exist only because we're here to observe it. The implications are staggering. If consciousness creates reality, then the emergence of consciousness wasn't just important, it was the most important event in cosmic history. It was the moment the universe woke up. Epilogue, the beautiful unknown. So here we are, 2025, the future our grandparents imagined. We have computers in our pockets more powerful than the machines that sent humans to the moon. We have AI that can write poetry and solve equations. We've detected gravitational waves and photographed black holes. And yet, we don't know what 95% of the universe is made of. We don't know if information can be destroyed. We don't know how to unify our two best theories. We don't know if consciousness is fundamental to reality. We don't know if reality exists without observation. In short, we know almost nothing. But here's the beautiful part. That's not a failure. That's an invitation. Every mystery we've discussed today isn't just a problem to be solved. It's a door to be opened. Behind each door lies a universe stranger and more wonderful than we can imagine. Dark matter might be particles that interact with reality in ways we've never conceived. Black holes might be windows into parallel universes. Consciousness might be the universe's way of understanding itself. Quantum gravity might reveal that space and time are illusions, and reality is something entirely different. The observer paradox might mean that consciousness doesn't just observe reality, it creates it. And AI might be the key that unlocks all of it. We stand at the threshold of discoveries that will make the revelation that the Earth orbits the Sun seem quaint. We're about to learn what we're really made of, where we really came from, what we really are. The universe is still writing its story, and we, conscious observers in a sea of cosmic mystery, we get to read the next chapter. The darkness beyond isn't empty. It's full of answers we haven't learned to ask for yet. And that is the most beautiful mystery of all. I'm PMC, and this is Photon Lab. If these cosmic mysteries inspired you, subscribe for more deep dives into the unknown edges of science. Share your thoughts on which mystery you think we'll solve first in the comments below. And remember, the universe is under no obligation to make sense to us, but that's what makes it so fascinating to explore. Until next time, keep questioning the impossible.